You have probably imagined it at some point in your life. Lifting something impossible, running faster than a car, flying above a city at night, completely unnoticed. Fiction has been telling you this story for 100 years. A radioactive accident, a hidden gene, a serum, a suit, a bloodline. Somewhere in that story, an ordinary person becomes something else entirely. And every single time, some part of you probably wondered, just for a second, whether it was actually possible. It isn't. But not for the reason you think. The real reason has nothing to do with science fiction being unrealistic. It has to do with something far stranger. Your body already knows exactly what it would cost to have those abilities, and it has spent millions of years calculating that the cost isn't worth it. Start with the simplest one, super strength. In fiction, a punch can send someone through a wall. In reality, the moment a human fist gains enough force to do that, the muscle, tendon, and bone required to generate it would need to be radically larger than what currently exists in your arm. Muscle tissue can only contract with a certain amount of force per unit of cross-sectional area, a limit that applies to every land animal on Earth, from a mouse to an elephant. An elephant is not stronger than a human because its muscles are more powerful cell for cell. It's stronger because it's bigger. Strength doesn't come from a special gene. It comes from mass. And mass comes with a price. More muscle means more oxygen required. More oxygen required means a bigger heart, bigger lungs, and a body constantly needing more food just to stay alive. Somewhere in your ancestry, evolution ran this exact calculation and decided that a body built to lift boulders would starve long before it ever needed to lift one. This is the pattern behind almost every fictional power you've ever wished for. Now, take flight. Biomechanics researchers studying flight, including work built on the foundational calculations of ornithologist and physiologist Colin Pennyquick, have shown that the physics of powered flight depend heavily on the relationship between body mass and wing surface area. As an animal gets larger, the muscle needed to generate lift increases fast, but the weight that needs lifting increases even faster. This is why the largest flying birds that ever existed, birds like Argentavis magnificens, with a wingspan over 20 feet, were already pushing against the upper limit of what flight allows. A human body, with the density and mass it currently has, would require wings so large they could not physically fit through a doorway, powered by chest muscles several times larger than what a human rib cage can support. Flight isn't a matter of ability. It's a matter of physics refusing to negotiate. Here is where the story becomes more interesting, because it isn't just that fictional superpowers are hard, it's that biology, left completely alone, has already tried to build almost every single one of them on other species, and every single time it hit a wall. Some fish generate electric fields strong enough to stun prey, but the organs required take up nearly a third of their body length. Some shrimp can see wavelengths of light no human eye can process, but the trade-off is a brain almost entirely dedicated to visual processing, leaving little room for anything else. Some insects can lift objects many times their body weight, but only because their small size means gravity barely affects them at all. The same insect, scaled up to human size, would collapse under its own weight, since bone and muscle strength increases with cross-sectional area, while body weight increases with volume. A mismatch that gets worse the bigger something grows. This is sometimes called the square cube problem, and it quietly limits almost every superhuman ability fiction has ever imagined. Every power you've watched on screen assumes you can simply add a new ability onto an existing human body. Biology doesn't work that way. Biology has to redesign the entire structure around a new ability, and something else always has to be sacrificed to pay for it. This is the twist most people never expect. The reason fiction feels so satisfying isn't because these powers are almost within reach. It's because fiction quietly skips the part where physics sends the invoice. A hero can fly without needing hollow bones, a 4-chambered heart built for extreme oxygen efficiency, and a metabolism fast enough to fuel constant flight. The same adaptations real flying animals had to evolve over tens of millions of years. A hero can survive an explosion without needing skin thick enough to stop a blade, bones dense enough to resist a boulder, and a nervous system that no longer processes pain the way yours currently does. In fiction, the ability appears, the cost disappears. In biology, the cost is the entire story. And once you notice that pattern, something else becomes clear. Every one of those trade-offs already happened in nature, just spread across different species, because evolution never optimizes for maximum power. It only optimizes for what keeps something alive long enough to reproduce. A species with claws sharp enough to tear through steel would also need a body strong enough to control that force without shredding its own tendons in the process. A species with skin thick enough to stop a bullet would sacrifice the sensitivity needed to feel a child's hand, or the temperature of water, or the texture of the ground beneath its feet. Every superhuman ability you've ever wanted comes bundled with a version of you that can no longer function the way you currently do. This is the part where the story turns back toward you, because there is one ability fiction almost always gets right, even if it rarely says so directly. Nearly every fictional hero eventually needs help, a team, an ally, someone to hand them information, cover their weakness, or finish what they couldn't do alone. That part isn't fiction. That part is the actual strategy your species has been using for over 2 million years. Humans never evolved individual superpowers. Instead, they evolved something rarer, the ability to combine limited abilities across many individuals into something that behaves like a superpower at the group level. No single human can outrun a car, but a team of engineers built one. No single human can survive in the vacuum of space, but a team of scientists built a suit that can. No single human can process the amount of information required to map a genome in an afternoon, but networks of researchers sharing knowledge across decades did exactly that. The fictional version compresses this process into one gifted individual. The real version spreads it across an entire species, over generations, and somehow that version turned out to be more powerful than any single ability could have been. So the next time a character in a story lifts a car, breathes underwater, or disappears into the night sky, it might be worth remembering what that scene is quietly skipping. Not impossibility, cost. Every one of those abilities exists somewhere in nature, in some form, at some scale, paid for in full by something else that species had to give up. Your species chose a different trade entirely. Instead of one extraordinary body, it built extraordinary cooperation. And unlike every other ability in the animal kingdom, that one keeps growing every single generation, without ever needing a mutation, a serum, or an accident to unlock it. You were never denied a superpower. You were given a slower one, spread across billions of people instead of one. And it has already taken you further than flight, strength, or invisibility ever could.